Hello, my name is Rama Charaf, and I'm here to talk to you about my NG1331 project that I did with Alberto Salgado and Ahmed Khairuddin. I want to start by stating that we chose to do the mechanics problem, which involved static equilibrium. I want to start by saying the static equilibrium is a very important concept in our engineering society today because it is important in many practical applications, including building design and bridge design. In order for, say, a bridge to have and maintain its desired shape, all of its parts need to be in static equilibrium in the absence of external forces. And I also feel that this concept is also important because it helps an engineer develop a way of a thought process of being able to calculate unknowns from very few knowns. So if we look here at our problem, we can see that we are given three variables: the length of AB, the distance, and the weight. And we are asked to calculate the two thetas over here, and then the length of LAC and the tensions of each string with the tension exerted, by the weight on each string. That's what I meant to say. So first we start by going through different steps, a different couple of steps, like making sure all the values are positive, and then creating a function to actually help solve for the tensions and for the thetas. So first we look at the problem here. I'm going to start by explaining to you the equations that we're going to be using. To find the theta, we're actually going to be using simple geometry, so we're going to be calculating different lengths using the Pythagorean theorem and the area of a triangle. And then from there, we're going to use the tangent function opposite over adjacent to actually calculate theta. So we're going to be using these two main functions to actually calculate the tension of 1 and then also the tension of 2 using the tension of 1. So we're going to start by first the housekeeping commands by clearing and closing everything, and then by uploading an Excel file that we have to create. We actually created the Excel file over here. It gives you different numbers for distance, for the length of AB, and for weight. And so we use this Excel file and we call it onto our code. So after we call it in, we actually have to extract each variable and the values that each variable has. First we find that if all the variables are positive. So we use a for loop. So we actually find first the size of the matrix, and then we use a for loop and the size of the matrix to actually go through every variable and make sure that it is positive. The if function is used to make sure it's positive, and if it's not, then it will be used with an absolute function, replacing any values less than 0 with the positive integer. And then it goes through all the variable until it ends. And then we check to see the same thing for the length of AB. We find the size, and then using the row and column, we find all the values less than 0 and replace them with the positive of that value. Then we do the same thing for the weight. So after we make sure that all the values are positive, we actually have to check and see if the length of AB is shorter than the distance, because as you can see in the problem, the length of AB actually is indeed shorter than the distance. So we start with a while loop. We have a counter for it to start, and then the while loop starts with the condition C is less than 1. And then the for loop is used to go through the row and columns of each of the matrices and making sure that the length of AB is greater than the length of distance in each one. So we go to the if function, and if it is indeed greater than the distance, then a warning will come up saying that it is greater and that a certain number should be subtracted from it for it to be able to work. And so then we ask the user to input a new value, and that value replaces the previous value of L underscore AB. And then the condition is met so that the while loop finishes. So after we do that, we have to actually determine the values for the length of AC. So to find the values of the length of AC, we actually have to develop a minimum value for the length of AC, which we did by subtracting LAB from D, and then we initialized it for a for loop. So the for loop goes through all the variables, all the numbers in the row, in the vector, and then the AC, the actual minimum value, will be increased by 2 every 15 times. So then the L underscore AC is actually replaced, the data from the LC will be saved in the new variable in the vector. So after we do all of that, we actually go on to our function. So first we start by naming the function by giving all the outputs, and then we give the name to the function, and then we give the inputs. So the purpose is to solve for the missing angles theta 1 and 2, and then using the 3 given variables. So first what's happening is we're finding the dimensions of the matrix using a for loop. So what we're doing to actually calculate theta is first we're finding the area of the triangles given the different lengths, and then that area is actually used to find the height of the triangle. So after the height of the triangle is found, it is going to be placed into the tangent function to actually find the theta of each angle. So over here you can see the for loop. The Heron formula is used to find the area, and then the overall area is found over here, and then the height is then solved for using this equation over here. So we find the rest of the lengths using the different Pythagorean theorems and whatnot, and then we use all of that information to calculate the theta. So theta is used using a function called flipped, and then the tangent function is used, and then that would give you the angles in radian. But then we need the angles in degrees, so we use the rad to degree function to actually calculate that. So after we do that, we plug everything into the previous equations given to us, and then we solve for tension 1, and then plug that into the similar equation and solve for tension 2. All of this is previously solved for above in the function. So we go back to our code and we actually call in the function into the code. So as you can see here, all the outputs are the same, and then the static function is given in, and then everything is replaced into new variables given the final theta and the final lengths of AB and AC. So the lengths of AB and AC are going to be given in non-real numbers because they're going to be Vic values, and so in order for us to plot them right, we actually made the numbers real. So then we start by plotting. With respect to AC. First you have the graph of AB, and then you have the graph of the tension of AC, and then you have all the elements, the grids, the labels, the titles, and the axes for each of the graphs. And then they're just plotted, and so if I run the function, there you go. So if I run the function, I'm sorry about that. So after we actually run the section, we're going to see that we have values greater than the distance, and they're going to ask us to replace it. So I'm going to say 18, and then they do the same here, 24. It asks us to replace it to subtract the value of 6. So we do that for each of them, and then it should work fine. All the values will come up in a second. So as you can see here, down here in the workspace, we have 15 values for almost each of them. And so if we want to look at the graphs, we should actually, if we actually look at the graphs of each of them, this is the length of, this is the tension of AC versus the length of AC, and then this is the tension of AV versus the length of AC. We can see here that we were asked to actually plot the lengths from the maximum of AB to the maximum of length of LAC. And so if this is the functions that we get. Actually, we are asked to run different test cases. However, if you look at our Excel file, you already have different test cases where you have the negative values become positive, and then the smaller distances of D are the larger distances of LAB are replaced with the smaller distances to be able to be less than the actual distance. And so you can see that our code actually works perfectly fine for a lot of different test cases. Our code helps with um, a lot of students and engineering learning because it explores different aspects of physics. You actually go from simple algebra, simple geometry to actually using more complicated calculus, and then you have using different formulas to find the tension and whatnot. And I really think that this code really is useful to any typical student in order to solve problems like these. So that will be the end of my code. I hope that everything is clear to you. We went from first checking using for loops and if functions to make sure all the numbers are positive, and then we use the same functions with a while loop to make sure that all the length of AB is less than the length of the distance. And then we found the length of LAC, and then we created a function that actually uses simple geometry to find the theta, and then using that to find the tension in each of the strings. So that's like a quick summary of everything that we went through. We actually ended up plotting each of the tensions with the length of AC, and we actually finished everything up. I think that's about it. Thank you so much for listening to me and for your time. Have a great day.